All right, here's another one. Now, when you look at this one, what do you see? Anybody? What do you see? Chris? You see secants here? Okay. Can I cancel these secants? No, I cannot. Okay. Because this secant has a -1. So this secant squared is a part of a difference or part of a binomial. We cannot cancel part of a binomial. So I can't cancel these, even if they're written above one another. Okay? And now the question I'm asking is not what can you do? I'm asking you what do you see? Okay? And I'll tell you what I see. And hopefully what you see, but you're too shy to speak up about. I see lots of squared terms. Do you see lots of squared terms? Okay? And specifically a squared term here that has a 1 with it. How many of these types of problems have we seen that had squared terms with 1s? At this point, enough, right? Enough to know that there's something I can do with that. So I'm not going to keep jockeying back and forth between the toolbox and the problems for you guys anymore. We've done this for 4 days. This is our 5th day, okay? At this point, when I say, and I'm not trying to put you on the spot, but when I say, what do you see? Right? Kind of a rhetorical question to get your mind thinking, okay, I see squared terms and a 1. I think I can do something with that. So, what do? We go to the margin. And we say, all right, this is the squared term expression that involves secant squared and the number 1. Can I do something to this to have it say that? Right? How many of these have we done? Quite a few. I want it to be secant squared -1, so I'm going to subtract the 1 over to the other side. Now it says tangent squared theta equals secant squared theta -1. There it is. So secant squared theta -1 can be replaced with tangent squared. So now this problem says tangent squared theta over secant squared theta equals sine squared theta. Now, keep in mind, I'm going to keep saying this every time we do a verification problem. I'm going to keep saying it. They're telling you what this should look like, what the complicated side should end up looking like. Okay? They're saying when this is all done, when you've simplified this as much as you can, you should have a sine squared. Well, look at this side. There aren't any signs here right now, right? But we could start that process by writing everything over here in terms of sine and cosine. So tangent, here comes the color coding again. Tangent squared is sine squared over cosine squared. Secant squared is 1 over cosine squared. And that's supposed to equal sine squared. So notice, all I'm doing over here is I just keep writing equals sine squared equals sine squared. I'm not really doing any math with that. I'm simplifying the complicated side. Right? You're going to hear me say that maybe a couple times. Don't complicate something that's simple. Simplify something that's complicated. Right? like this looks way more complicated than that. So I'm going to simplify this. Pythagorean substitution, writing everything in terms of sine and cosine. And again, you know what's coming out, right? If we had a classroom full of 30 people, I said, what do you think I'm going to do next? I bet there would be one person that would go like this. Ah, yeah, right? You knew it was coming, right? Patrick got it. You know it's coming, okay? Hopefully this isn't like a gang sign. I don't know what gang signs are, okay? But what are we going to do? We're going to take the bottom, we're going to take this one, we're going to flip it over, and we're going to multiply, okay? I promise I mean no disrespect to your gang if I'm doing this, all right? So we do this, we flip it over, we multiply. So we're going to take that, we're going to flip it over, and we're going to multiply. And when we do that, where'd my pen go? This is going to be cosine squared theta over 1. I'm just going to, okay, just going to do it. I'm just going to move it up there. And now when I multiply these, what happens? We cancel on the diagonal, right? And we have sine squared theta over 1, if you want to write it that way, which is sine squared theta. Check mark. Look, do I have to then waste the lead from the pencil or ink from the pen to write this as sine squared theta just because that's it? No. We know that sine squared theta over 1 is equal to that. Check mark. Done. We did it. Okay? Yay.